Okay, the equation for the first ellipse, let's see, here and here. So my center is at, where's my center at? -2, 0. A is going to be 1, 2, 3, 4, 5. And B is 7. So I've got x plus 2 squared over 25 plus y squared over 49 equals 1. Number 2, my center is at 0, -1. A is 7, B is, looks like 2. So I've got x squared over 49 plus y plus 1 squared over 4 equals 1. And then for number 3, it looks like the center of my circle is right here. So my center is at 4, -1. A is going to be 1, and B is going to be 1, 2, 3, 4, 5, 6, 1, 2, oh yeah, 6. So let's see, x minus 4 squared plus y plus 1 squared over 36 equals 1. Okay, so there's your questions for your warm-up, answers for your warm-up. So we're moving from ellipses to our last conic section, which is called hyperbolas. Okay, so a hyperbola has a fundamental triangle, and it looks, this is the triangle right here. I'm sorry, fundamental rectangle. Wow, I can read really well today. Rectangle, and you can see the little rectangle in here. It's all dotted up. With corners at 0B, 0, -B, A, 0, and -A0. And the diagonals of this rectangle are the asymptotes, and you can also see that they're the dotted lines here. They're the asymptotes, so the lines don't cross, my hyperbola curve doesn't cross those asymptotes. And so you can see the little rectangle in there, and then the asymptotes. And we are going to, oh my goodness. Basically, to graph these, we're going to find the distance from my the center, which is the center of those asymptotes. That's the center of my hyperbolas. And then I still have my A, which my distance horizontally, and B is my distance vertically. So I still have all that information that I'm going to be working with to draw out my hyperbolas. The difference is in the equation. If you look, I have two different equations. I have one that opens horizontally, and I have one that opens vertically. Okay, the equation looks very similar to the ellipse. The difference is instead of a plus, we have a minus in the middle, so I'm subtracting the 2 instead of adding the 2. They still equal 1. And then if my hyperbola opens horizontally, which is this way, right, my x value comes first. If it wraps around the x-axis, so if it curves around the x-axis, or the x one, because it doesn't have to curve around the x-axis, but you can kind of see that it is, even though my center is not on the x-axis, it kind of wraps around this x-axis here. Then the x comes first. If it wraps around the y-axis and opens vertically right here, then the y goes first, okay? So that's how I know which way it opens horizontally or vertically. And that's really important, especially when I'm writing the equation, to know which one it is. And also, please pay attention, because B still goes with Y and A still goes with X no matter which position it's in, okay? So those are the big things about the hyperbola that where people get mixed up, is they put the A with the B, A with the Y, because it thinks A always goes with the first term. It isn't. Y and B go together, and X and A go together, okay? So try this now. Okay, so it says, write the standard form of the equation of each hyperbola. So we still need to know our center, A and B. We still need to know that information. So the center of my hyperbola is where my asymptotes cross. So my center is going to be at, let's see, -1, -2, it looks like. Okay. And then you can, there is a little box in here, although you can't really see it. This one is really bad at seeing the little box in here, but it goes, let's see, it's going to go here, here, here. Here's the rectangle. Sorry, it's right there. So my distance A is the distance here. So that's 1, 2. And B is my distance vertically. And again, that's still 2. So there's my A and my B. Okay. And then my hyperbola wraps around my x-axis. That means X goes first. X goes first. Okay. So I've got X plus 1 squared over 4. And this is a hyperbola, so it's subtract. And then I've got Y plus 2 squared over 4 equals 1. Right? Is that okay? Not too bad? Okay. Number 2, most of the rest of them are pretty easy to find the rectangle. They're kind of drawn in. These two, they are not. So it's a little bit more difficult. So my center is at 0, 0. And then A and B. So I can draw this out here. It's going to go out and touch my, my asymptotes, because the asymptotes go through the corners of the rectangle, which makes it really easy to find out where it's at. So A is going to be 1, 2, 3. And B is going to be 1, 2, 3, 4, 5. Okay. So, and it's opening around the y-axis, so Y goes first. So I've got Y squared over 25 minus X squared over 9 equals 1. Questions? Pretty easy? Okay. Glad you two think so. There's 4 problems for you to do. Maybe we'll go ahead and do this. Here we go. So let's see. This one, you can actually see the rectangle in here, so it's a little easier. My center is at 0, 0. A is 3, and B is 3. So, and it's opening around my x-axis. So I've got X squared over 9 minus Y squared over 9 equals 1. Okay, to do minus. Whew. Okay, and then B, my center, oh, I can leave that here, I think. There we go. My center is still at 0, 0. And A is at 2, and B is at, 2. Okay, and it's opening around my Y goes first. So I've got Y squared over 4 minus X squared over 4 equals 1. Questions on those two? Okay. And then C, my center is at, where's my center at? 1, 2. And then A is 1, 2, and B is 1, and it looks like Y is going first. So I've got Y minus 2 squared over 1. Actually, I don't have to put it over anything. Minus X minus 1 squared over 4 equals 1. Okay. And then D, let's see, center is at 0, negative 1. A is 5, and B is 1, 2, 3, 4. And X goes first. So I've got X squared over 25 minus Y minus 4. Looking at the wrong thing. Y plus 1 squared over 16 equals 1. Questions? We're okay so far? Not too bad, right? Pretty easy? Awesome. Okay. So now we're going to identify where the hyperbola is centered, the vertices of each, A and B, and then sketch the graph, including the asymptotes and the fundamental rectangle. Awesome. Okay. So my center of my circle is at 0, 0. A is, what is A? 3. And B is 5. Okay. So I'm going to go 0, 0. And A is 3. 1, 2, 3. 1, 2, 3. And 5. So I'm going to kind of draw a rectangle in here because it wanted me to sketch that in there. And then you know where your asymptotes are. I mean, the vertices of your rectangle are at negative 3, 5, negative 3, negative 5, positive 3, 5, and positive 3, negative 5. There's where my corners of my vertices are. And then it wants to sketch in the, I'm going to be really bad at this. Oh, that was pretty good. The asymptotes. So there's my asymptotes. Well, one of them. I missed the corner a little bit, but all right. There's my second asymptote. And then my X comes first. So my X is first. So that means it's opening horizontally. So here is where my hyperbola is going to touch. Okay, my hyperbola is going to touch my fundamental rectangle, and then it goes along, right, my asymptote. So it's going to be kind of this wide hyperbola. It's going to touch right there, and then it's going to come out here, and it does this on both sides. Oh, that one's so not as good as the other side. But it looks like this. Whew. Thanks, Matt. Any questions? Is that not too bad? Not too bad. Okay. So, okay. I guess I need to put it into the right form first. So I'm going to divide by 100, right? So I get y squared over 100 minus x squared over 4 equals 1. So my center of my circle is still going to be 0, 0. And A is going to be 2, and B is going to be 10. Whew, okay. And it's going to open, let's see, Y is first, so it's going to open vertically. So it's going to open vertically. And then A is 2. So I should have vertices at -2, 10, -2, -10, 2, 10, and 2, -10. Oh, and we don't have 10 on here. So we're just going to pretend that's 10. That's a beautiful one where the graph doesn't even fit. Okay. And of course, it's probably opening vertically too, right? Okay, and then your asymptotes. Those are really bad asymptotes. Okay, and it's opening vertically, so up here is where my hyperbolas are going to be. And, ooh, that was bad. There we go. Should look something like that. Chris Hansen. Okay, any questions on those first two? The other, I should have probably changed the scale on it, but I didn't, sorry. It would have made it fit on the graph a little better. Okay, so 3 and 4 are a little different because now I need to pay attention to where my center is moved, right? So my center on 3, my center is going to be 1, -1. A is going to be 2, B is going to be 3. So I should have vertices at 2, 3, -2, 3. I probably should have put this in here because I'm going to get them wrong here. -2, 3, 2, 3, -2, 3, and then 2, -3, and -2, -3. There we go. Okay. Whew. Oh, that is so not where they're going to be at because my center of my circle is not 0, 0 anymore. Oh, my Lanta. Okay, let's put the center in first. 1, -1, and then 2 over 1, 2, 1, 2, 2, 3, 3. Totally messed that one up, didn't I? So I've got a vertice, a vertice of my rectangle at, let's see, where is it at? -1, 2, and -1, 4, and then I've got it at 3, 2, and 3, oh, that should probably be -4, -4. Sorry, forgot my negative sign. And then I put in my asymptotes. Beautiful, and it's opening horizontally. So here and here's where it should touch. Oh, that's a really bad arrow on the end of that one. It should actually touch there. Sorry, I didn't get it to touch. Okay, pretend it's touching. Imagine that it's touching. I can take the whole thing and move it backwards a little bit. Okay. And then 4. Okay, I know it's going to open vertically. Where's the center of my circle at? Someone tell me where the center of my circle is at. 2, -1. Good, yeah, because it goes to the x first, right? Very good. So it's 2, -1. Awesome. And A and B are the same this time. So A equals 2 and B equals 2. Awesome. So remember the x coordinate is always with my x term and my y coordinate is always with my y term. So if the y comes first, I got to flip them. So I'm at 2, -1. And then I've got 2, 2, 2, and 2. So there's my rectangle, and my vertices are at where's that? 0, 1, and 0, -3. And then I'm at 4, 1, and 4, -3. Okay, so these asymptotes should be easy to draw because it's just up 1 over 1. Okay. Okay, and then it's opening vertically, so it's going to touch here and here. Oh, okay, that wasn't a very good curve. Neither was that one, but you guys get the point, right? Questions? Okay, and the page, I think it's your turn to try. Awesome, go for it. Maybe we can, okay, there we go. Maybe it'll let me write here. So my center is at 0, 0. A is 4, B is 5. So 4 that way, 4 that way, 5, 5. Oh, shh. There we go. So at -4, 5, -4, -5, 4, 5, and 4, -5. Those are my vertices. My asymptotes. That one's a little crooked, sorry. And it's opening vertically, no, horizontally. Oh, that's a bad curve. There we go. Whew. Number 2, oh my goodness, divide by 400. So y squared over, I don't know what 400 divided by 16 is. 400 divided by 16. 25. 25 minus x squared over, I bet it's 16. And then equals 1. So my center, again, is at 0, 0. A is 4, B is 5. Should look almost exactly like the other one, only opening in the other direction. My vertices should be 4, 5, 4, -5, -4, 5, and -4, -5. Since my center is 0, 0, that one's pretty easy. 4, 4, 5, 5. 3, 4. 1, 2, 3, 4. Okay, so yeah. And I didn't quite touch, but there you go. There's that one. Let's see. C, my center is at So we're doing horizontally. And my center is going to be at -2, +1. And then A is 3 and B is 5. So -2, +1. 1, 2, 3, 1, 2, 3, 5, 5. Let's see, vertices are at -5, 6, and -5, -4, and then 1, 6, and 1, -4. And it's opening horizontally. Okay, so ooh, there we go. And then my last one, let's see, what is the last one? Center is at, where's my center? -2, 0. -2, yeah, -2, 0. A is 3, B is 6. So we've got -2, 0 is here. 1, 2, 1, 2, 3, 3, and then 6 and -6. So we should have -5, 6, -5, -6, and then 1, 6, -1, 6. Oops, I think I went too far on that one. There we go. Ooh, that was a horrible dash line. We'll just put a little dash in there. And then it's opening vertically. So okay, is there any questions, you guys, on hyperbolas? How is it? Not too bad?